Okay, today we have Hood Chatham, who's going to tell us about a progress report on the spectral sequence software.
Right. Okay. So, right. So this is joint work with, well, Dexter, I guess. We're very sort of, I mean, I'm not very good at like keeping in touch, so we sort of do our things, and we've been gradually sort of taking inspiration from each other's work. So it's sort of a loose collaboration, I would say. But it's been very helpful. Yeah, so this is progress report and roadmap. Just hopefully I'll go a little bit under time on this, and I'm kind of curious to sort of solicit some input from other people here about what sorts of things, what sorts of needs they have, what sorts of the tools they wish existed. But I certainly have my concept for what I think I'm trying to make. So as an outline, I have sort of some specific project goals. In particular, I have a sketch of a chart system for making and curating charts. What's the status? Well, I've been a bit distracted, so the status hasn't really moved that much. But I'm going to talk about some of the sort of my sort of overall design philosophy and some of the sort of challenges to getting software that is going to be usable by a general audience. And I really don't, like if people are going to make their own charts and say like host them on their own web pages, well, I'm getting sort of ahead of myself. And then I'll give a brief explanation of what I have been up to, which regarding like what I've been doing instead of actually getting this finished. Then maybe see what people have to say. Okay, so that's sort of my overall idea of what I'm planning to say. Maybe I want this to be the other direction. Okay, so the project goals. Now, of course, here it's very important to pick something that isn't too ambitious so that it stands the chance of ever being completed, which is already, difficult. But sort of my main ideas about things that I want to have. So one is a web viewer for charts. And of course, this exists in various prototype forms. You've seen, the ones on my website. I just got embarrassed sufficiently badly about these being broken that I fixed them. Now hosted on a different website because the UCLA math server sucks. But I have a link to it on my UCLA webpage. It's the same stuff as always. So I'd also like a web editor for charts. That can be used by, for public use. Now, of course, this already puts much stronger constraints on how mature the system has to be, because if you, again, go and make save files, then you want that to be forward compatible with future versions of the viewer. You don't want me to change things and break your pictures. So that's sort of a concern that I've had. 3 is a toolkit for building. Sort of interactive chart editors for specific goals, for specific projects. And so this, I mean, so a lot of the interactive charts on my website, I had prototypes of these, I made one for Danny to make this BPC81 chart. I had a prototype with Dan to name and choose bases in X data that Brunner and Rognus gave us. And so this is something where it's like, there's sort of no way to get away from the need for some web programming to make these sort of interactive tools. So I sort of have some like general use things, like I have a matrix display that you can do like an editable matrix over FP, and these can be combined in various ways, but it's really hard to get away from the need for web programming for this. And if you could do that, you would solve a much harder problem of like, all sorts of people are concerned about this issue. Well, okay, I'll talk about this more in a minute. But okay, so anyway, so this is going to be something where it would be like you would get into contact with someone like me or Dexter and work together on a specific project to use one of these, or maybe eventually we could have like general purpose instances of this if it turns out that one particular tool set is useful for a lot of different projects. Of course, an example of 3 would maybe be like Dexter's like eXT web editor is another example of that, which is based on our Rust resolution software. And he has this front end where you can input differentials and do various stuff. I'm not even sure what exactly. Right, and so related to that, a 4th purpose is maybe, we want a nice program interface for charts to interact with other programs that produce, like resolvers. To sort of solve the display part of any program like this, because in some sense, any resolver, like the linear algebra or like, differential graded algebra stuff that you do is really distinct from the work you have to do to get a nice display. And I think it would be really good if we could sort of separate these 2 problems, and like there's going to inevitably be lots of different special purpose computing programs. But I think that it is possible to solve sort of a lot of the display problems, maybe not every possible variant, but for most purposes to solve the display problems once and for all, so that people who are good at writing, say, C or Rust to make resolvers don't have to go become web programmers or think about like, output, we can maybe handle the PDF or web output for you with this interface. Right. So our sort of existing success story, I mean, I would say is, I think the biggest success story here is the LaTeX package. And so I sort of think that this has many features that lend itself to like a successful, it's self-contained. There's a limited interface, so there's a limited set of tools that are available for working with it. I only just finally feel like my maintenance approach to this is like recently I've finally gotten this to be something that I think is going to be maintainable long term, which I think is really important, because again, you don't want, as people buy new computers and install new versions of LaTeX, you don't want eventually for your software to sort of rot and people have to go and figure out what old version of LaTeX supports it. So anyways, I think there's various features of this LaTeX package that made it very well suited to something that could be successfully resolved. And I think that for me, when I'm thinking about like what my goals are for future projects, it's important to sort of think about like what can actually be done. So because we have a limited amount of programmers that are working on this. I mean, it's me and Dexter, and then there's some of these other particularly grad students who've been putting in some work on this stuff. But there's a limited amount of expertise in a lot of these areas that this requires knowledge about. And so if we need to make things that are possible with the amount of effort we have available to us, and we need to make things that are possible to maintain in the long term, because I don't think it serves the community well to make something that's going to break in a few years. That just, yeah, wouldn't be good. So, right. And then I have usability goals, right? So I really want this stuff, at many of these things I would like to be sort of as accessible as possible, given the sort of constraints of the universe. So the viewer, should be lightweight, reasonably lightweight web page. Should be compatible with various browsers. Mobile, etc. So the viewer should be sort of as accessible as possible, given editor. So I'm willing to accept constraints. Still I would like this to be browser based to avoid the need for installation for people who are just picking it up or using it for some light project. But maybe limited to Chromium. Chromium has, particularly I like this native file system access that you can actually just like load and save files to the person's computer. Firefox considers this to be like an unacceptable like security flaw, which maybe it is, but for this sort of application, it's very helpful. And so it doesn't heavier. This can be a heavier download. 10 megabytes or something. It still isn't humongous. I mean, the New York Times front page is probably more than that, but and maybe not really for mobile. Particularly iPhones. Probably it'll be usable on Android devices. And then these 3 and 4 are probably these are going to be requiring more instructions could involve either more technical abilities or some specific tech support. Okay, and I guess so I can give some vague idea of what I think that this how I think this chart system should work. I hope I'm not boring you guys. So let's see.
There is a
Sorry.
there is a question in the chat. Doug asks if chromium means chrome.
Yeah. So Chromium is like Chrome, but then there's also like a bunch of other, so there's a browser actually called Chromium. There's a browser called Chrome. There's Brave and there's Edge, and many others. So Chromium is the sort of open source base for Chrome, and there's a whole bunch of browsers that are based on it. But Chrome is, yeah, it's really, it would be Chrome is the one that you're most likely using. Like if you run Linux, then they don't like Google that much, so they usually have the open source versions with the Google stuff removed. Okay, so I guess I want to say vaguely what the chart interface looks like. So this is going to be fairly familiar. It's similar to the LaTeX package, but the idea is that we're going to be, I want to make this in Python. I mean, there's also a possibility of using something like Lua, which is a little bit more lightweight for embedding, but I'll get back to that in a minute. So, one of the annoying things about LaTeX is that it's a very limited sort of programming environment. It doesn't really make a lot of sense. I mean, there's like looping constructs. You can have like a macro, but it's not really like a function. And, I mean, of course, we make do with it for, for making these charts. I added various looping constructs, but you end up trying to solve a lot of problems that like a better programming language would like not have to begin with, that are just, LaTeX doesn't work very well style problems, but in a real language, probably Python. And so basically, it's right. You have pages, you have classes, and then there's like various types of edges, which they break down into like struct lines, which are fairly general purpose, and then differentials and extensions, which are really sort of special cases of struct lines, but they are commonly used. So it's useful to have these sort of out of the box configurations for these. And then these all have, various, various graphic primitives that control controlling stuff like color, for the edges, like, like, is it solid or dashed? Shape. And each of these sort of display primitives is going to be parameterized over the page. So these will depend on the page. So you can do something like set the color of a certain class to change to red on page 5, and that would look something like this. And so then, the LaTeX package makes certain assumptions about what you're likely to change, but over time, it's, the trend has been that people sometimes want to change any specific thing. Like you might want the tooltip to change on some page, you might want the color to change on some page, you might want the shape to, so basically everything is going to be parameterized over the page, so that like you can say, okay, like there's some interesting differentials of some event on page 5. So starting with page 5, this class is going to be red here, or something like this. And so then there's things like, class labels, which need to be, LaTeX drawn onto the canvas. There's things like tooltips, sidebar information. There's the goal of LaTeX export, And this is actually a really important design goal, because the thing is that like LaTeX is a very different sort of system than the browser rendering system. In fact, in a lot of ways, the situation is kind of reversed when you get to like graphics and LaTeX, where it's like LaTeX has this TIX package, which is a very impressively high quality graphics language. And compared to that, I mean, the browser stuff is interactive, but it seems remarkably impoverished when you compare it to BGF TIX, which is kind of bizarre and depressing, because you would think that there's just so much more energy devoted to the browser, but there's really no, like, if you just have a TIX diagram and you want to like out of the box draw it into the browser, there's nothing that produces as high quality of an output, or even like particularly close. Like you can do a lot of work and start to get approximations, but there's just like a lot of little features where it's like, TIX will find the convex hole of your shape for you automatically and end your edge at the boundary of that. But if you're going to do this in the browser, you start having to write convex hole algorithms, or find someone who wrote the convex hole already and pull that in, and then like figure out what the scaling transform is to make sure that it lines up correctly. And then there's some little error, so the edges sometimes drift away. There's all of this stuff that just works out of the box in TIX. So this is something that I don't know who the people who do PDF TIX is, like, Tillman Tantau or something like this. These people are amazing. I just really want to emphasize what an incredible package PGF TIX is. But anyway, so this is an important design constraint for basically everything. Specifically, when it interacts with the like weird equivariant homotopy theory glyphs. So this has been something that sort of I've spent a fair amount of time like worrying about, like how to get these like weird shapes that equivariant homotopy theorists like to draw into these canvases in the browser in such a way that when you move, if you try to move it to LaTeX, it looks the same. And already just getting LaTeX onto a browser canvas is like not that easy, but anyway, so this is something that has been like worrying me over time. But I think that with enough sort of force of will, it's possible to get these details to work out. It's really in the little details that you start to run into these troubles. And maybe like extra like arbitrary paths that you can draw on top of them. Labels. Anyway, so this is a sort of package that I'm looking at. Again, it's sort of the same feature set as in the LaTeX package. It will, like, in a real programming language, it feels somehow much better, because every time you have to like do a loop, it's like just like the amount of like pain that I experience like trying to write like the most basic programming constructs in LaTeX is like it's high, right? You face all these sort of mental barriers, but like Python has like sane looping constructs, like it has functions. You don't have to worry about like macro substitution, that sort of stuff. So the same stuff is just much more usable in that. And also we can have like a live editing of charts. So instead of having to like have a like script that you write that upfront makes the whole chart, you can sort of have a script, and then you can like look at your chart and be like, oh, let me change this color of this thing to be red, and then you can see what happens, and then you can sort of save that into the script. So I think that like for sort of live computation, right? I mean, the LaTeX package was really designed with the idea that it would be for displaying stuff that you've already computed, but almost immediately people started using it to do like new computation. And it's not the ideal tool for that by any means, but it's sort of, I mean, of course, like I think with iPads now and sort of better drawing tools, you can sort of undo, you can save a template, but without that sort of tool, you spend so much time just drawing your grid carefully, and you make too many mistakes and you have to copy it over, and so people ended up doing the stuff in the LaTeX, and for actual computational purposes, this is very valuable. anyways, so these are sort of the goals. And this is like reasonably self-contained. You know, of course, another important goal is like thorough documentation. Documentation, testing, maintenance plan, maintenance, so that it doesn't break next year. And this stuff actually takes up a lot of time. So yeah, so basically the state this is in is that it's sort of like 90% exists. You know, each little aspect of this I've prototyped and like I've prototyped like significant groups of them. And sort of the main issue is so issues here are I'm just bad at finishing things. And the last few details take up a lot of time. Sort of. Right, particularly like, you know, making sure that it doesn't break next year. And, you know, and you have to think about stuff like versioning for save files so that, you know, if I update the chart save file, then you want to like say, oh, this is version 2. And then we want to make sure that we can still load version 1 save files so that people's old stuff doesn't break. And there's a lot of specific concerns about like, you know, making like things that you could do to make people's lives miserable that like you want to like know to avoid before you get there. Okay. Anyways, so I think that with, you know, particularly with encouragement, you know, I mean, you know, part of the issue I've had is I haven't been in that much contact with people who want this to exist since the pandemic. And so I sort of drift over to working on stuff where it's like people are like asking me to do things. And so like, for instance, like in preparing this talk, I went back through and figured out like, where am I with everything? And, you know, sort of regained a lot more motivation to like focus in on this stuff. So, you know, I mean, I sort of like, and I think that one thing would be good for me is to have like specific projects that rely on subsets of this functionality. Because I mean, I find it really hard to like, you know, so in the long term, I lose motivation when I don't have collaborators. But anyway, so that's the sort of gist of what this is going to look like. So I've used up about half of my time. And so I guess, you know, I mean, I'm planning to go under on time here because I don't need a full hour for this, but I can use some extra time to just like give my opinions about various things. Let me see, what have I written here? So I have to decide whether I want to say this stuff. Right. I mean, another thing that takes up a lot of time is my sort of mentality that like as much of this as possible should be like browser only. And that sort of fits into this sort of general, like, you know, I mean, there's sort of a world of different like approaches to software compatibility, right? So it's sort of a classic problem that each person's computer maybe has different libraries available on it. And you want to make a program that is going to run on many different people's computers. And you have to worry about what the environment looks like and whether your program is compatible with that environment. And there's various approaches to this, which is so like one approach, for instance, is like to go like Windows only. And Windows has like a sort of legendary backwards compatibility thing, you know. So if you had some closed source program that was written in like 1995 and where the sources have been long lost to defunct companies, and then your still using that, and you want to upgrade to Windows 11, but like you still need to use this program that was written under Windows 95, and it still works. You can do that. Macs and Linux are not really designed like that. So, I mean, another approach is to sort of identify a like least common denominator of like what libraries are likely to be available on modern computers. So like this is the approach that like Python takes for like, Python wheels. They have this architecture called mini Linux, which is based on like, oh, like in 2014, this is the worst Linux we think any reasonable person would be running. And so we're going to make sure that if you were running the worst Linux, this library would still work. And then more and more people are moving towards this thing called containerization, where they basically are shipping like replacements for all the libraries. They're shipping like a full little operating system with their program just to avoid worrying about what's on people's computers. And this is sort of, I mean, it gets rid of the like environment dependencies, but they tend to be huge. They use up a lot of RAM because like you're not using system libraries. They're slow, but they install everywhere. So this containerization is sort of a movement that people have been going to. So then we get to the browser, where it's like that the browser is sort of like a runtime that your computer already has that does paper over like Linuxes or Windows or Macs. It doesn't, you don't really care which of those you have. It introduces new compatibility issues because each browser itself is a slightly different runtime. And so depending on what browser version the person's running, you have to now support all those different browser versions. And so we've sort of replaced the problem of like which Linux, which Mac, which Windows with like a sort of new problem of which browser, but that's sort of a smaller moving target. And the browser comes with these really nice sort of user-facing, user interface APIs that are much better than what the programs offer natively. And everyone has browsers. And in particular, almost everyone has some version of Chrome lying around, except for on their iPhones. So anyway, so that's sort of why I've been sort of, in some ways, kind of caught up on this idea of putting things into the browser. Like I think that in some ways it's caused, I could have gotten something out much earlier without this design constraint, and it's not clear whether that was necessarily like a good decision, but like it's what I've ended up doing. And so it is true that like, for instance, I was talking about how like imagining to have this toolkit for building chart editors. Like imagine you had a toolkit like that could be used by someone with like limited programming experience. They could just like swap out something and add, mix and match components and make some like chart editor. In fact, you could almost be solving a much more general problem that almost everyone in like data science and like, all sorts of different like user end stuff want to solve, which is like the web is increasingly sort of inaccessible to normal humans. You have to know a lot about web programming to make one of these things. And if you just like have an idle interest, it's really not something that you can do. And so in the old web, you look at an HTML page, pretty much anyone, with some patience can figure out how to make a basic HTML web page. And so I think it's sort of an issue of concern in the broader web, particularly for like data science and stuff like this that also benefit from these visualization type things, and would really like to have like people who aren't web programmers be able to make interactive programs. And so one thing I would say is that a lot of the stuff that I'm dealing with here, I'm sort of running into broader issues where it's like actually a whole bunch of people want to solve this. And if I'm reinventing the wheel, maybe I'm making a worse solution. But in some places, some of these things I've done are actually interesting to people who are, in all sorts of different areas, particularly in programming and education. So that sort of ties into like I've gotten distracted a lot with this Python runtime. So there's this project called Pyodide, which runs Python. This is a browser port of Python. And it's compatibility focused. So as much as possible, it will behave exactly the same as your native Python that you install on your computer. And so in order to like run these scripts like that are written in Python, I want to put them in the browser. And so I got into this PyDide thing. And then, like Dexter started going in and fixing the upstream PyDide issues. And it turns out they have a lot of needs there. So I ended up spending a lot of time working on this project. It's kind of cool because like we have downstream users, like basically all of the French public high school system uses this for its CS education. In French public high schools. And we also have like Microsoft has products based on us that if you go on the Jupyter Notebook webpage, you will see advertised this thing called Jupyter Lite, which is based on us. Anyway, so this is something where it's like by reinventing the wheel, like a lot of the stuff I've done is just worse than the existing solutions and was a waste of time. But some of the things are actually like useful for all sorts of other areas, unfortunately. And so I've gotten distracted with being useful for all these other areas, and I should probably get back to being like useful to homotopy theorists. Anyways, so that was what it's been 40 minutes. So I think I could stop with that, and I would love to hear your questions or comments, what things you wish existed, etc.